Hey class, this is lesson 3.2. The objective is to use addition or subtraction to solve inequalities. For the review, less than would be this sign, greater than this sign, less than or equal to, at most, no greater than, as much as, no more than, looks like that. Greater than or equal to, at least, no less than, as little as, no fewer than, looks like that. All right, equivalent inequalities are inequalities that have the same solutions, right? An inequality that is equivalent to the inequality that is given. Since 10 is greater than or equal to -3, that means -3 is less than or equal to 10. Since -7 is less than -1, -1 is greater than -7. If b is greater than -10, then -10 is less than b. If h is less than or equal to 0, then 0 is greater than or equal to h. The equations that are not equivalent to x equals 3 are x equals 1/3 and x plus 2 is equal to 5 minus 2. The inequalities that are not equivalent to x is less than or equal to 3 are x is less than or equal to 1/3, x plus 2 is greater than or equal to 5, because that would mean x is greater than or equal to 3. So that one we're going to cross out, and the last one we're going to cross out. That would mean x is less than or equal to 1. We'll do this problem tomorrow in class. Our concept here is the addition and subtraction properties of inequality, which are pretty much the same as the addition and subtraction properties of equality, just with inequality symbols. Basically, the idea is if you have an inequality, you could add the same thing to both sides of the inequality, and you still have an equivalent inequality. Same with subtract. You can subtract the same amount from both sides of the inequality, and you have an equivalent inequality. So, since 3 is greater than -1, that would mean that 3 plus 5 is greater than -1 plus 5. Since 4 is greater than or equal to 9, 4 plus n must be less than or equal to 9 plus n. If z is less than 8, then z minus -4 is less than 8 minus -4. And w is greater than or equal to k, then w minus t is greater than or equal to k minus t. What are the solutions of x plus 9 is less than 12? We're going to use the subtraction property of inequalities here. We're just going to subtract 9 from both sides. And we get a new inequality that's equivalent that says x is less than 3. Now when I graph this, since x is less than 3, 3 is not included in the solution, so I'm going to put an open circle at 3. And then I'm going to shade all numbers that are smaller than 3. And that would be numbers like 2, 1, 0, -1, and so on, and then keep going. Anyway, you get the idea. There they are. All right, now to check that answer, we are going to check our boundary point. So we want to make sure that that point solves the related equation. So 3 plus 9 has to equal 12. Even though we know that's not a solution, we just want to check that point and make sure it's true for the related equation, and it is. And then we want to check one of our solutions, and you could actually pick any one of these, any number, even like 2.5, but I'm going to choose the first one. So I'm going to do 2 plus 9 and check to make sure that is actually less than 12. and 11 is less than 12. So that's true, so I think I have the right solution. All right, go ahead, do problem 1. And the answers for problem 1 are, we're going to add 5 to both sides. So we get n is less than 2. And n is less than 2 is, this graph has an open circle because we're not including 2. And then it shows all numbers that are smaller than 2. All right. To solve this inequality, 7 is less than or equal to x plus 3. I'm going to use the subtraction property of equalities. Take away 3 from both sides, and I get 4 is less than or equal to x. And remember, that is the same as x is greater than or equal to 4. So we need to graph all numbers that are higher than 4 or equal to 4. So we're going to put a closed circle at 4. And we are going to shade everything higher than that number. All right? And then we want to check 2 things. We want to check and make sure our boundary point is correct. So we want to check 4 in the related equation. I'll do that over here. I want to make sure 7 is equal to 4 plus 3. And that's true. So that's good. Then I want to check one of my solutions, something up here. 5 seems like an easy one to check, so I want to make sure that 7 is less than or equal to 5 plus 3. 7 is less than or equal to 8. That is true. So it seems like I have the right solution. All right. So if we're trying to solve m minus 11 is greater than or equal to negative 2, to isolate the variable, we are going to add 11 to each side of the equation. So that's going to look like this. And we get the equivalent inequality. Negative 2 plus 11 is 9. So we get m is greater than or equal to 9. To graph that, we have to include 9, which is halfway between 8 and 10. And then we have to show everything that's above that. So numbers like 10, 11, 12, 12 and a half, and so on. So that's my solution. And then I want to check 2 things from that solution. I want to check and see if my boundary point 9 solves the related equation. So 9 minus 11 is negative 2. And I want to check and see if a number that I have shaded here, like maybe 10 or 11 or something like that, also is a solution to the inequality. So 10 minus 11 is negative 1, and negative 1 is greater than negative 2. So yes, those both check. We should have the right solution. All right, so we have t plus 3 is greater than 1. So since we're adding 3 there in the equation, it makes sense to subtract 3 to solve it. You probably notice I say equation when I should be saying inequality quite a bit. But this inequality, their equivalent inequality when we subtract 3 from both sides, is t is greater than negative 4. And then we want to check those solutions. So if my graph t is greater than negative 4, I'm going to put an open circle at negative 4. And I want all points that are higher than that. So everything to the right of that I need to shade. So all of these numbers from there and on to infinity are solutions. And then I want to check 2 things. I want to check the boundary point to see if that is a solution to the related equation. So I want to make sure negative 4 plus 3 is equal to negative 1, and it is. That checks. And also I want to check one of these solutions that I highlighted here, like any number along here somewhere. So I'm going to check negative 3, make sure that's a solution to the inequality. So I'm going to substitute negative 3 for t and do negative 3 plus 3, make sure that's greater than negative 1. Negative 3 plus 3 is 0, and 0 is greater than negative 1, so that checks. So it looks like I probably have the right solution. Okay, on problem 3, got it. We want to solve for negative 1 is greater than or equal to y plus 12. So we're going to subtract 12 from both sides. And when we do that, we end up with negative 13 is greater than or equal to y. If I graph that, I have to include negative 13, so I'm going to use a solid dot at negative 13. And for negative 13 to be greater than or equal to y, that means y is less than or equal. All numbers less than or equal to negative 13. Numbers less than are to the left of. So I am going to shade that way. And then I want to check my boundary point, which is negative 13 in the related equation. So I want to check and see if negative 1 is greater than or equal to negative 13 plus 12. Actually, I want to check and see if that is equal to. So I want to make sure negative 1 is equal to negative 13 plus 12, and negative 1 is equal to. So that part of the solution is correct. And I also want to check a point that is in my shaded area, like negative 14, and make sure that solves the inequality. So if I do negative 1 is greater than or equal to negative 14 plus 12, and negative 14 plus 12 is negative 2, and negative 1 is greater than negative 2, so I'm good. All right, problem number 4, applying this. We're going to let B equal the size of the video stored. And we're going to let B plus 115 is equal to the total stored on the computer. And then we can write an inequality that says that my videos plus the stuff I already have on there has to be less than or equal to the total that the computer can hold, which is 250 gigabytes. If I solve that, I subtract 115 from both sides, and I get B is less than or equal to 135, and that means I can store at most 135 gigabytes of videos. In this problem, at least that means greater than or equal to. So we're going to let P equal the plants that are sold Friday, and then we're going to create an equation to represent the situation. 8 plants sold Wednesday plus 9 plants sold Thursday, plus P is greater than or equal to 25. Then when we simplify and solve that inequality, we get P is greater than or equal to 8, so that means the club members must sell at least 8 plants on Friday. Here are the answers to the lesson check, and I'll see you tomorrow.